Hello and welcome to day 2 of finding all solutions or the general solution for some trig functions. We did cosine yesterday, finding this arc cosine, and today we're going to work with arc sine and arc tangent. This lesson is just going to focus on arc tangent. There'll be two video lessons to watch. All right, let's just warm up with what was done yesterday with cosine. In order to undo the cosine function, we arc cos both sides to undo it. So we get theta equals the arc cosine of 1/2. And there's a definition for that. Let's just get familiar with where cosine is positive on the right side. And to equal 1/2, the adjacent is 1/2. That means the opposite's root 3 over 2, making this a 30-degree angle. And as you learned yesterday with a little trick, that's actually negative 30 there. And our formula looks like plus or minus the inverse cos of 1/2 plus 360 n. So we would write the general solution is theta equals plus or minus 30 degrees plus 360 degrees n. That's the general solution. On the specific interval given from 0 to 720, we just use this to generate all the values that are greater than 0 and less than 720. Certainly 30 works. If you add 360 to 30, you get 390. Another 360 added is 750. No, that can't be. We're done with those. Now we have to try the negative 30. And when you do negative 30 plus 360, you just get a 330. And adding 360 to that, you get 690 anymore, and we get over 720. So that is the solution to this problem. That's just a reminder. And from out of this is where we got this plus or minus inverse cos stuff. And if we're in radian mode, remember that a cycle takes 2 pi, not 360. So let's look at tangent here. For tangent, the graph, remember, for positive tangent, all scholars take calculus or the opposite over the adjacent. If it's positive, it's in quadrant 1 or quadrant 3. And equaling 1, it's a 45-degree angle. You've got a root 2 over 2 and a root 2 over 2. Both are positive, or down here, both are negative. And the ratio of the same number over itself is a positive 1. So this 45-degree angle here, or this reference of 45, is what we're going to use. And tangent has a unique property where it really repeats every 180 degrees, not full 360. So we don't even really work with this on a fundamental basis. We just work with the 45 degrees. And we would say that when you arctan a tangent, you eliminate it. So it's theta equals the arctan of 1. And I'm looking for the angle whose tangent is 1. Well, 45 degrees certainly works. Okay, so the inverse tan, I'll write it like that. And then if you notice here, this angle over here is just 180 degrees out of along the unit circle. So if I just added 180 to this value, or even subtracted 180, basically I could get the same ratios. So what we're going to do is add 180 n, which again, adding can be subtraction when n is negative. So the inverse tan we figured out was 45 degrees. You keep adding or subtracting 180 degrees, you're going to find all values. We actually want just the values from 0 to 720. So theta will equal the 45. Add 180 to that, you get 225, and those two angles look familiar. However, if we keep adding the 180, we get 405, I believe, and another 180, 585. If I go any further than that, I get over the 720. So we'll stop there. That is our answer. Okay. That goes kind of fast. Let's do another problem and just start to distill down what the main idea is here. Again, we're going to try to find all the angles. And so to find all the angles, we undo tangent with arctan. If you do it to one side, you have to do it to the other. I get theta equals the arctan of root 3. Basically asking what angle does tangent produce a root 3 ratio, or root 3 over 1 we could write. And what we wrote before was inverse tan of root 3 over 1. And then it was a plus 180. Let's just make sure that's going to work again. If we look over here, we're looking for opposite over adjacent. So root 3 being opposite, and positive is going to be in the top, the first quadrant there. So opposite root 3, adjacent 1. That reminds me that's a 1, 2 root 3. That makes this a 60-degree angle. Okay. Well, it's also positive 180 degrees further along. That'll get taken into account with a plus 180n. So our general answer for tangent of theta that equals root 3 is inverse tan of root 3 over 1 we figured was 60. If we keep adding 180 or subtracting 180, we'll get all answers. We want just the values from 0 to 720. So 60 certainly works. We don't want to go negative. We add 180, 240. That should look familiar from the unit circle. Adding 180 again, it's 420. And then another 180 gives us 600. Go any further, I get past 720, so our final answer is here. Now that went kind of fast, so you might want to look back at both of these problems and try to find what's happening and be ready to write some notes and ask in class. To generalize what we've just done, we took the inverse tan, and instead of adding 360, we've added 180 because that's all that's required for tangent. But we didn't have to do a plus or minus. That is gone from the cosine answer, but now instead of adding 360, we only add 180, or if it's in radians, we add pi n. All right, let's try looking at circles here. I'll do this problem, and then we'll have one for you to try after this slide. So tangent of theta is opposite over adjacent. So it's positive up in the first quadrant again. We're going to work with a negative, and that gets a little bit tricky maybe, but opposite 3, adjacent 5, undo tangent with arctangent. We get theta equals arctan of 3/5. Trying to work with that formula, we get the inverse tan of 3/5 plus 180n. And when we get this, I'm going to need a calculator. So I get into the correct mode, and I am. And I do second tan, 3 divided by 5. That doesn't look right. Did I change the mode? I did the tangent. Let's try second tan of 3 divided by 5. That looks better. 30.96 we're going to say. So theta, in general, theta is going to equal 30.96 degrees plus 180n. The great answer, and it gives all solutions. Why don't you try this next one? We're looking for x to equal the arctan of 4.3, and just as a heads up on that, essentially you can think of this as the tangent of x equals 4.3, and the first step was already taken. Do the arctan on both sides to undo tangent, and we get this equation. So from here, make sure now you're in radian mode and get to work. Okay. Let's work with our formula here. We know that the inverse tan of 4.3 will be some value. In this case, we're going to add pi n because we're given x at an interval of 0 to 4 pi, so that's radians. I'm going to check my mode, get to radians. And I simply take the inverse tan of 4.3. I get 1.34 radians plus pi n. And to help you get a sense of where 1.34 is, if you look at a unit circle, you're going to see this is roughly 0 to 6.28. That's what 2 pi is. Over here is 3.14. So 1.34, well, pi over 2 is half of 3.14, so 1.5, almost 6. So this 1.34 is going to be in the first quadrant. That certainly makes sense because I have a positive value. So 1.34, not a number I'm going to be comfortable with because it's radians and it's really multiples of pi, but it certainly looks like it's in the correct quadrant anyway. So if I get all my values, I'm going to get x equals 1.34. I'm going to add pi, but I'm not going to do that in my head. I'm going to do plus pi, that's second caret. I get 4.48, 7.62. All right, let's see if I can write all these. And then it was a 10 point something. 7.7. And there's all my answers from 0 to 4 pi. And if you think about it, 4 pi is some number 12 point, let's see, 4 times 1 is 4, so 12 and a half-ish or whatever. If I add 3 to 10, I'm going to get over 13. So clearly I'm under, and there's no value greater than 10.77 that gets me in that domain. Let's try another one here. Very similar looking problem. Go ahead and hit pause, and notice now you're in degrees, and you got to go negative to positive, so it's a little different domain. Okay, using my formula, I want the inverse tan of 9.4 plus, in this case, 180 n. So get the calculator back up. .66 degrees, 66.04 we'll say. No, we won't. We'll just go with 66 in this case. So maybe I can do the math in my head here. I get theta equals 66 plus 180n. And on the interval from negative 360 to 360, I certainly get 66. And if I add 180, I get 246. When I subtract 180, I'm going to get a negative value, negative 120, or 114. And another 180 from that, and I get negative 294. I hope that's right. And these are all in degrees now. Okay, so for on your own, try doing these problems here. Do the cosine, get familiar with that, and then also the tangent. We'll see you in class.